Hi, in this video we'll continue the discussion on exception handling using Java. In the previous video you must have seen how we can declare exceptions and then how you throw exceptions and how they're caught and handled. So we looked at the declare, throw and catch aspects of exception handling. Today we'll look at, we'll introduce a new concept called rethrowing exceptions. So now there is a chance, there could be situations where a method is able to handle the exception, but then there is a possibility that its caller, its parent method might have some more additional information about the exception that occurred. So there might be some use in handling it and then rethrowing it so that the other handlers in the caller method, they get a chance to process it and provide any additional information. So that's what is called rethrowing exceptions. So in terms of syntax, I mean, there is no new keyword called rethrow. It's just the same throw again, but the difference is that so we have a try block with the statements where an exception could occur, and then we have the catch handler wherein we have all of the statements that are to be executed in order to handle the exception. So once the handling is done, then we can say throw the exception object, and this is the rethrow part. So basically that's doing the rethrow. So what it's going to do is it's now going to throw that exception object to the caller of the method. So any handlers in that caller method can then pick it up and provide additional information. So that's the idea of rethrow. We use the same keyword throw again, and after the handling is completed, just say throw the exception object. Another useful keyword to know is finally. So basically there's this finally clause or a finally block that's typically specified at the end of the try catch. After all the catch blocks have been specified, then you have this finally blocks. It's basically like the final statements. Anything that you want to be done, like say files have to be closed, or some sockets are to be closed, or any kind of final operations that are to be performed can be performed here, or maybe certain objects need to be set to null. All of those kind of statements can be specified in the finally block. Now the idea is that the finally block will get executed under all circumstances. It doesn't matter if the exception occurred or did not occur, and if it was caught or not caught, the finally block is always going to get executed. And that's the reason we have any of those final statements, closure statements in there. Like, you know, if we were performing some file operations, then typically closing the file is in the finally block to make sure that the file gets closed properly in spite of any exceptions or errors that occurred in the code. So what happens is, say all of the say no exceptions occur, then all of these statements get executed successfully, and then the finally block gets executed. Say instead an exception occurs in one of these statements. If an exception occurs, then we're going to look for a corresponding catch handler. The handling code gets executed. So say all of the handling of the exception that gets executed, and then the finally block gets executed. So like I said, it's always executed under all circumstances. So it's useful to have it in your code with any of those final statements. So let's look at some program execution. We'll look at we'll trace some programs so you understand the flow of execution, especially because we have so many different kinds of blocks. There's the try block, and then there's the catch blocks, and then there's the finally block. So we'll look at what happens in different scenarios. So this first scenario here, suppose so we have a try block, and then we have some corresponding catch handler, and then we have a finally block with some final statements, and then there are some next statements after that. Say in these statements here, no exceptions occur. So nothing bad happened, everything went fine. So in that case, what happens is this whole block got executed, and then finally all of the final statements get executed, and then next statement gets executed. So that's what happens. Now say we're in a different situation. The try block has 3 statements and an exception occurs in statement 2. And this exception is of type exception 1. We're just making it up. It's of some type exception 1, and it's thrown here in statement 2. So then what happens is there is a catch block corresponding to exception 1. So this the handling code, handling of EX is done, and then the final statements are handled, and then the next statement gets executed. So that's what happens when an exception occurs and it is caught, handled, and then the finally statements are executed. Now here's another case where an exception occurs in statement 2 and it is of type exception 2. In this case, you see we have multiple catch blocks that are to handle the different exceptions. So in this case, because it's of type 2, we're going to start with the first one. We'll try to match here, it doesn't match, and we try to match here, it matches. So it will basically handle the exception. It will execute the handling EX statement, and then after that you see that there is a throw statement. So that's a rethrow basically. But then the moment we rethrow the object, the control goes to the caller. So what happens here is it will execute handling EX, and then it gets to the finally statement, the finally block, and then it executes all of the final statements. And then the control goes back to the rethrowing part, and then the exception is rethrown to the caller. Now in this case, next statements don't get executed. Finally gets executed, but then next statement does not get executed. So that's important to note. That's the significance of having a finally block. It's always executed. Now some cautions when using exceptions. So like I said earlier, there is a lot of overhead when exception handling is used. So overuse of exception handling is not a good thing. It does use up a lot of time and resources because it requires the instantiation of a new exception object. So whenever an exception occurs, a new exception object is created to hold the information of what happened at that point. So also I forgot to mention, when this new exception object is created, to the constructor we pass an error message, but along with that there's other information, as in which method of which class did it occur, at what time it occurred. So there are a number of other things that are automatically getting stored in that new exception object. And then there is a lot of code that in the call stack basically keeps track of a number of things, so that if we need to roll back, it's able to roll back, and it propagates the errors to the calling methods and so on. So a lot happens in the call stack to keep track so that the rolling back and propagation is possible. So because of that, that's the reason I say it uses up a lot of time and resources, and hence we don't want to overly use exception handling, and use it where it makes sense. For simple things like checking if an object is null, it's just easier to add an if statement and check if that object is not equal to null, then go ahead with the processing. Similarly, division by 0, that's a simple check. Just check if the number is not equal to 0, and only if that holds, then perform the division. There's no need to create a new exception object and go through all of this process for those simple things. But then it can be very useful for other more complicated tasks. It is nice to have exception handling because it's basically separating out the normal programming tasks from the error handling part. So it makes the programs much more easier to read and modify. So in that sense, it really improves the readability and the maintainability of the program. But having said that, for simple things, it's still we should avoid using it. Now, when to throw exceptions, like I showed you two ways in which except whenever say you're using an object that has checked exceptions, and then you're forced to use exception handling, and there you have to decide whether you're going to handle it yourself in the method where it's occurring, or do you just throw the exception. So basically the way to decide on that is to see if you have sufficient information to provide and handle it. If you don't have that sufficient information at that point in that method, then it's basically you pass it to the caller and allow the caller of the method to handle it. So that's how we decide when to throw exceptions versus when to handle, or when to handle exceptions. When to use exceptions, I just mentioned, like for example, if we have a variable called refvar, and then we want to print it out, we want to invoke its toString method and print it out, having a try catch block like this for a simple, just because refvar could be null, and if it is null, then the toString method will fail, and if that happens, then the program will crash. But then instead of having the cumbersome exception handling for that, we could just replace it with a simple refvar not equal to null, then print it, else just say print out an error message saying refvar is null. So it can be, when it's this simple, we don't need exception handling. The last thing that we'll look at is how to create your own exception classes. Earlier I showed you the API and all of the existing exception classes in there. Our goal should be to use whatever is existing wherever possible, as much as possible. But then there could be situations where sufficient information is not there in them, and you want to create your own custom exception class. So that's possible. You can basically extend any of the existing ones. You can extend the generic exception class, or one of its subclasses. You can extend any of its subclasses to create your own custom exception class. So I'll quickly show you an example. We'll use the same circle with the invalid radius. We'll use that as our example. So let me show you the code for that. So here's the invalid radius exception class. So the way you create your custom class is, so basically give it your custom exception name and extend one of the existing exception classes from the API. In this case, I'm extending the generic exception class. And then the data member would be, and so why do we want this? Why can't we just use the illegal argument exception? Now say we want to indicate the radius and its value, and why it is invalid, why it's illegal. Rather than just saying that the argument is illegal, if you want to provide more information, and if you want to provide the specific radius that was passed, then those are the kind of situations wherein there's some extra custom information that we want to specify in that exception message. So that's when we create our own custom exception classes. So here what we are able to do is have a data member called radius, and then when the exception occurs, so in the constructor of invalid radius exception, we are basically taking in that radius and setting it to this radius field. So that way when we print out the message, the error message, instead of just saying invalid radius, we can say -5, invalid radius -5. So the user has additional information of what was it that was not correct about it. And then there is a get method to get the radius. So here you see that we are using the we're invoking the super constructor. The reason for that is so that the parent class, which is exception class, its constructor is also invoked, and then this message over here is the error message. So typically when you create a new exception object, we pass an error message to the constructor. So we're passing this error message to the constructor so that the parent constructor also is getting called. So that's how we create a custom exception class. Let's look at how this is used. So in fact, the previous example that we saw in the previous video, it did use this invalid radius exception. That's right. So let me show it to you. Here you go. So this was the circle example. So we're creating a circle class with the radius exception, and then in set radius, we're saying that it throws an invalid radius exception. That's our custom exception class. And then when we create the exception object, we're passing the radius to this to the constructor, so that the radius value gets stored in that exception object. And then when the handling happens and the error message is printed out, it would print out the value as well. So again, if we go back and test that, use a test circle example. Let's see. Yeah. So I basically tested, I ran the test circle with that was using the exception, the custom exception class. So if you look closely at the error message, it says invalid radius -5. So it's providing additional information about the exception that occurred, and then it's printing the number of objects as well. So that's how it works. Again, like I said, custom classes are created only when it's really needed, and when none of the existing exception classes in the API, when none of them are fitting the purpose, or if there's some additional information that you want to store in the exception object, that's when you would create a custom class. So that's all I have on exception handling. Thank you.